Yeah, and good lingo.
Exactly. You gotta get them into fighting.
Oh shoot, we're recording.
My bag.
My bag.
My bag.
All right, at the top, so we remember it, let's write the integration by parts formula. So we have u times dv, and that's what we're trying to pick a u and a dv for these things. And then this is how we're gonna find the integral. And if you recall, I showed you this yesterday. You might have not understood it, but this was reversing the first d second, second d first product rule. Okay, you do not have to memorize this, by the way. Okay. So our rules for picking u were that we wanted to make sure that the derivative of u was simpler than u, and our rules for picking dv were that it's something we can integrate. All right, now that doesn't necessarily help us out a ton here because really those apply to both, but I'm going to let u be x. That's what I'm going to pick. I'm going to underline these things, and dv I'm going to pick to be e to the x. All right, so those are the things I pick. And then maybe I can color code this. These are the things I need to find then. What would du be? Just 1 dx. And going backwards, what would v be? Just e to the x. Okay. All right, now, what we're going to try to write down is this formula. So I'm going to write it out. Okay, so I'm just going to double check that I have a u, that's my x, and I have picked dv to be e to the x. Alright, so I'm going to write u times v, so what am I going to write? X times e to the x, and then minus the integral of e to the x, and in place of du, I'm going to put dx. Alright, one more time. Integrate this. What's the integral of e to the x? E to the x. So we do equals x times e to the x minus e to the x plus c. That's it. Okay. Now what's this rinse repeat business?
Is that talking about if you have, like, for instance, if the integral of v du is just a single term?
We do it again, yeah. Okay, so then I'm going to show you, hopefully, at the end, if I have time, something called tabular integration, because with repeated integration, what you can do is make this cool table thing kind of nifty and save some stuff. So I'm going to go and do this again, and this time I'm going to let, well, what do you think I'm going to let u equal this time, if I kind of was using the same method as last time? I'm going to let u be x squared, and dv is going to equal e to the x. Okay. Alright, and then du is 2x dx, and what's v? E to the x. Alright, so I write out this formula. Okay, I'm going to do u times v. So x squared times e to the x minus the integral of v du. So what's v? E to the x. And what's du?
2x.
Okay. So this is where the rinse repeat comes in. It's not really rinse repeat. It's making fun of a
Not even
shampoo.
rinsing as well, it's just repeat.
It is, but it's like if, yeah.
It's not like return to go, collect $200.
Kind of, yeah.
Then you don't actually collect it.
So up here, when we had the integral of e to the x, it's just e to the x. But here, do you see how this is an expression like we started with? So I'm going to put this over here, and I'm going to put a little 1 by it. That's what we used the first time. Now, I'm covering this up. To do this integral, we're going to have to do integration by parts again. All right, but let's not freak out. It's the same thing. What's u going to be this time? 2x. Basically, I need to get all the way down to that constant, which is going to be 2 dx then, right? Okay. And then our dv is once again going to be e to the x. Okay, don't forget that this is here, okay? Don't forget this is here. Because I'm now going to just do this part, and then at the end I'm going to put it all together. Okay? Alright, so, I'm not going to forget about this little guy. To do this part right here, I'll do it in blue, I do the integration by parts formula again. So, u times v, using this one. So, what am I going to write? 2x. Just so you're clear, this is what I'm doing right now. The integral of that. 2x times e to the x minus the integral of e to the x, 2 dx, because that's something I can integrate now. Okay. And we're not going to forget at the end that that's there, right? Oh, sorry. Okay, so what I just did in blue here was the integral of this part. I'm not going to forget that that's there. All right, so putting this all together, let's drop this down. The first thing I have is, from before, x squared times e to the x minus this whole expression, right? 2x e to the x. And then what's the integral of e to the x times 2? It's just 2 e to the x. We can, plus there's lots of things that you could do to simplify this, but what I'm going to do is, absolutely, Dana, you could factor in e to the x out, and then you'd have x squared minus 2x plus 2, actually. Okay, but what I'm going to do is, just lastly, I'm going to get rid of that subtraction sign by just distributing it. So that's just x squared e to the x minus 2x e to the x minus 2 plus 2 e to the x.
So they're because you're kind of doing the integrals and an integral, you only have to just put 1 plus c at the end.
Correct, because it's a compilation of all the c's, kind of like we were talking about before. Now, I want you to notice a pattern here, and this is where the tabular integration in a second comes into play. Do you see this first one as an x squared? And what about this one? 2x. Isn't that the derivative of that? That's, you know what I mean. And then 2. Okay? What we are able to do once you have higher powers, I'm going to show you in a second, like an x squared or higher, is basically you can set up a table to do this pattern and keep integrating one expression or deriving one expression down and integrating the other expression, and then you can get a little way to find what those terms are, because there is a pattern with that. So I'll show you that at the end. Yeah.
On our homework, we had a question exactly like this, except
I thought it was like this one, wasn't it?
It was. We had one like 4, I think we had one like 5 too.
Okay.
Except for instead of e to the x, dv was secant squared, so b was tangent. But then when we went to integrate again,
You write it as sine over cosine then.
so an integral of 2x times sine over cosine dx.
Yeah, because then, I don't know, I'll look at it. Okay.
That was really
Let's do this one. And so this is my rinse repeat. I'm going to give you, hopefully, I hope I have time. I'm going to give you the ones that match up on your homework so you kind of see what strategy they are. This one, at some point, we are going to set an expression equal to the original, or set the equation equal to the original expression. But what do you guys think we should pick for u and dv in this case? Well, I like v to be well, you're right, because it's the sine and cosine can go back forever. But since I'm going to be integrating, I'm going to pick the e to the x to be my dv because it's not going to alternate signs. Okay, so I'm going to put dv to equal e to the x, and then u to equal sine x, which means du would equal cosine x dx, and v would be e to the x. Question, Danny?
Does that mean that we're not going to be able to do it? Because every time you integrate sine x and cosine x, you're not going to get a constant?
You'll see. Okay, so then you're taking away the element of surprise. All right, so let's look at... We are going to be able to do it. We're not going to get all the way to the end and I'll be like, no, can't do it. You just wasted 5 minutes of your life. All right, so that's our formula again, right? So we need u times v. So what are we going to write? Sine x times, yeah, I'll write it down here, what I'm doing, minus, not equals. Alright, so, sine x, oh, where was I? E to the x, right? Minus the integral of, v, which is e to the x, cosine of x, dx. Okay. It's a little trickery. So then, it's like, whoa, we got to do this business again, right? Is that what you're seeing? Is that what you were trying to say, Danny? Okay. So now I would pick u to be cosine of x, right? Du would be negative sine x. dv would equal e to the x, and what would v equal? Okay. Watch what happens. I'm getting excited, so I'm forgetting dx's. Alright. So I'm going to rewrite this. I'm not changing it all. But now to do this part, I'm going to do integration by parts again. So I write u times v with my new little guy. What's u times v? Times e to the x minus the integral of Can I just do this instead of negative sine x? Did you guys see what I just did? Just pulled it out to the front and made it a plus. Okay. So, are we all comfortable with that so far? Now, do you remember in the beginning, what we were trying to evaluate, what we're doing so far is we're evaluating what integral? What we started with, correct? So, I'm going to write here equals the integral of e to the x sine x dx, because that's what we were trying to find, correct? Okay. So what I'm going to do is I am going to